Good morning, student. Today we will discuss that while changing rational numbers into decimals form, then what are the methods? Okay, this is the last topic of this chapter. Means all rational numbers can be converted in decimal also. Now here, while converting rational numbers into decimals, we are having two particular types. Number first, terminating decimals, and second, non-terminating decimals. Okay, again I am repeating. When we are changing any rational number into decimal, then there are two possibilities. Either it will be terminating decimal or non-terminating decimal. Now, terminating decimal having two particular method by which we can operate. Okay, the first method, converting denominator to power of 10. Okay, power of 10 means you can see if you will factorize prime, if you will do prime factor of the power of the 10, it will give you 2 into 5. If you will take 100, then also you can see it will come in the form of 2 and 5. Means their factor will be 2 and 5 only, not any other prime number. Okay, so whenever we will converting means rational number into decimal form, and for checking that it is terminating, then the first method we can make the denominator in the power of 10. Now look at here. So I will explain you with the help of these examples. It is easy for you. 10 upon 25. So you have to do the prime factor of 25. So prime factor of 25 you will do. You will get 5 into 5. Okay. So 10, 5 square. Now look at here. You can see the denominator. It is now 5 square. To make it in the form of 10 means the base will be 10. Then what we have to do? We have to just multiply denominator and numerator with 2 and with the same power. Okay, 2 square. Because I just told you just before few seconds that whenever you will factor 10, 100, 1000, then your prime factor will be 2 and 5 only. And here when you have factored 25, then you get only the term which is in the form of 5. Okay, so making the denominator as base of 10, we have to check that we have to means our required number is 2 to power 2, and we have to multiply in numerator and denominator both. Okay, now see what happens. In numerator it will come 10, 2 square means 4 upon here 5 square multiply 2 square. Now, according to the rule of the exponential form, when powers are same, then multiply the base and put power one time. Now, 5 into 2, these are the base, their powers are same. So, according to the law of exponential form, we have to multiply the base and cover the bracket and put power one time. Now, you get 40 upon 5 into 2, 10, 10 square. Then after 40 upon 100, 10 square will give you 100. Now 40 upon 100 simplify, 1 0 will cancel, you will get 0.4. Okay, so this is the first method to convert denominator to the power of 10. Now take one more example here. 4, if you will do the prime factor of 4, you will get 2 into 2 and 1 upon 2 square. Now see, here the required is 5 and the power which is on 2 will come with the 5, and we have to multiply in numerator 5 square as well as in denominator. Now 1 multiply 5 5s are 25 and here you can see 2 square into 5 square, 25 upon. Now again the base are different but power are same. So according to the law of exponent, we have to multiply the base in bracket and put power one time. Here 25 upon 10 square, it will give you 25 upon 100. Okay, and it will give you 0.25. Here means changing rational number into decimal, and while checking it is terminating or non-terminating. So in terminating, this is the first stage which I had discussed, making denominator to the power of 10. Clear? Next method is log division. Log division in the sense, here division comes to end, means when you will start doing your divide, okay, numerator you will divide from the denominator, then at the end in the remainder you will get 0. The division comes to end, it means remainder should come 0. Let us see with the example. 3 you have to divide from 2. It will go one time. Divide not possible decimal. 2 5s are 10. Okay, now see here 3 upon 2 you can convert in the form of 1.5 in the decimal. Now see minus 1 upon 8, again the same process. If it is having minus sign, keep the minus aside. Okay, and do the log division. I am doing here 1. You have to divide by 8, divide not possible 0, then put decimal, 0 will come here. Divide 8 2s are 60, 8 1s are 8, 2 0, 8 2s are 16, 4 0, 8 5s are 40. So you can see you get minus 0.125. Clear? So in terminating decimal, we have to check two methods. Anyone we can. If question suggests find the decimal form of any given rational number by the making denominator to the power of 10, then we have to utilize this, or it says by the division method, then like this. Okay, so again I am reminding you, in the terminating decimal there are two methods. Number one, making denominator to the power of 10, and second, log division, where remainder comes as 0, means division comes to end. Clear? Now come to the non-terminating decimal. In the non-terminating decimal, digit or set of digit in decimal part keep on repeating, means here in the non-terminating we have to do the normal division. But what is the main thing? Digit or set of digit in the decimal part will keep on repeating. Let us see one example. Here minus, keep it aside. 5 you have to divide from 6. Divide not possible 0, decimal 0. 6 8s are 48. 2 0. 6 3s are 18. 2 0. 6 3s are 18. 2. You can see it will continue. It will goes on. Okay, so you can represent it in a short way. Minus 8 0.833 dot, or you can say like this, minus 5 upon 6 minus 0.83 bar. Means if any digit or set of digits keeps on repeating, we in a short we can write upon bar on that digit. Okay, so changing any rational number into decimal form, then we are having two methods, terminating decimal or non-terminating decimal. For finding terminating, there are two particular methods: converting denominator to the power of 10, and second one by the log division, where division comes to end, means remainder will come 0. And for the non-terminating, we have to do the simple divide, and in this where division is keep going on, means remainder should not come equal to 0, and after the decimal, means the decimal part, any digit or set of digit keeps on repeating. Okay. Now, while discussing this both method, sometime question can ask that without doing long division, how you can check that given rational number is terminating or non-terminating. Okay, so it is very simple. You have to just follow this one for that. If your denominator power means if in the rational number, suppose I am giving you one example. Suppose 7 upon 21. Okay. Now, if I will do the factor of this particular denominator, prime factor, I will get 3 into 7. Now you can see here in the prime factor, we are not getting 2 or 5. Okay. So directly you can say, while doing the prime factor of the denominator, if you will not get the factor 2 or 5, okay, on either any one, then you can say it is non-terminating. Okay, it is non-terminating. And where you will get the prime factor as 2, as 5 or both. Okay, either you can get 2 also, either you can get 5 or you can get both. Clear? So you can say if your denominator prime factor will be 2 or 5 or both, then that particular rational number will be terminating decimals. Clear? So today you have to revise this, and this is the last topic of the chapter. Okay, thank you.